Okay, so yesterday, first of all, good afternoon to all of you. Yesterday we have started unit number 3, and unit number 3 is combined bending, torsion and thrust. So yesterday we have discussed how to find out shear stress due to torsion, how to find out normal stress due to bending. After that we have derived equation for principal stresses. So which formula we have to use for finding out principal stresses. Okay. After that we have discussed how to find out maximum shear for solid circular shaft and maximum shear stress for hollow circular shaft. Okay, and I think we have solved one numerical in last lecture. So today we will continue remaining numericals. So I request all of you, please write down next example. Write down next example. Okay. So a solid circular shaft. Next example. A solid circular shaft. Solid circular shaft. Solid circular shaft of diameter 120 mm, of diameter 120 mm, diameter 120 mm, carries bending moment, carries bending moment and twisting moment of magnitudes of magnitudes, twisting moment of magnitudes 35 kilonewton per meter, 35 kilonewton meter, 35 kilonewton meter and 25 kilonewton meter, 25 kilonewton meter respectively. Full stop. Find the major principal stress. Find the major principal stress. Find the major principal stress. Find the major principal stress induced in the section and where does it develop? Where does it develop? Where does it develop? Where does it develop? So here in question we have to find out major principal stress and where does it develop? That means principal planes. Okay. So this is the question. Now we will solve example. So first we will write given parameters and then we will solve. Okay. So you read problem and tell me which parameters are given.
Diameter of circular shaft.
Okay. So D which is equal to 120 mm. After that next.
Bending moment M is equals 35 kilonewton meter.
35 kilonewton meter. So we have to convert into Newton meter, Newton mm. So anyone please tell me how to convert kilonewton meter?
35 into 10 to the power 6.
Okay, good. 35 into 10 to the power 6 Newton mm. Okay, 3 for kilonewton to Newton and 10 raised to 3 for meter to mm. After that next parameter is twisting moment. So T which is equal to 25 kilonewton meter. So again we have to convert. So T which is equal to 25 into 10 raised to 6 Newton mm. Okay, so that much parameters are given. So now we will write which parameters we have to find out. To find. So which parameter we have to find out?
sigma 1 upon sigma 2 mana. Sigma 1.
Okay. Sigma 1 which is equal to question mark, sigma 2 which is equal to question mark. Here only major principal stress is asked, but we will find out both stresses. Okay. And then where does it develop? That means principal plane also. So theta 1 which is equal to question mark and theta 2 which is equal to question mark. That much parameters we have to find out. Okay. So now first we will apply our equation for finding out major principal stress. So next step is find principal stresses. Find principal stresses. Find principal stresses. Okay, please wait 1 minute. Which equation is used for finding out principal stresses? Yes, anyone?
16 by
16
pi
of d cube divided into
pi cube.
Okay, 16 pi d cube in bracket
M plus minus
M plus
under root m square plus t square.
t
Okay.
square.
So 16 divided by pi d cube in bracket m plus minus square root of m square plus t square. So sigma 1 comma sigma 2 which is equal to 16 divided by pi into d is 120. So 120 cube into m. The value of m is 35 into 10 raised to 6 plus minus square root of 35 into 10 raised to 6 bracket square plus 25 into 10 raised to 6 bracket square. Okay. So you observe here in these three terms, 10 raised to 6 term is common. So we will take it as this is common. So 16 into 10 raised to 6 divided by pi into 120 cube. So what is remaining in bracket? 35 plus square root of 35 square plus 25 square. So you calculate and tell me sigma 1 which is equal to how much and sigma 2 which is equal to how much. Yes, sigma 1 which is equal to how much?
दोनशे 32.00
232.
229.92.
2
230
232 is wrong answer. 2
229.92.
yes, correct answer. 229.92 Newton per mm square. Okay. So Kekan, please check you once again. Then sigma 2 which is equal to
Minus 23.61.
okay minus 23.61 Newton per mm square. So this one is the major principal stress. Major principal stress, and last one is the minor principal stress. Minor principal stress. Minor principal stress. So next step is we have to find out principal planes. Okay. So find principal find principal planes. Find principal planes. So which equation we have to use for finding out principal plane? Anyone have remember?
Tan 2 theta
Tan 2 theta, which is equal
T
to
upon M. T upon M.
T upon M. So tan 2 theta, which is equal to torque is given. Torque is 25 into 10 raised to 6 divided by moment is 35 into 10 raised to 6. So this 10 raised to 6 and 10 raised to 6 gets cancelled. So tan 2 theta, which is equal to
0.714.
0.714. Therefore, 2 theta, which is equal to tan inverse of 0.714. So 2 theta, which is equal to
35.52.
35.52 degree, and therefore theta, which is equal to 35.52 divided by 2. So theta 1, which is equal to how much?
Seventeen point seven six.
70.76.
76.
17.76 degree. So this is the major principal plane. Major principal plane. And next we have to find out minor principal plane. So therefore theta 2, which is equal to theta 1 plus 90 degree. So theta 1 is 17.76 plus 90. So theta 2, which is equal to
Minus 72.24. No.
1071 चे 7.76 म्हणून
107.76 degree, and this is the minor principal plane. Minor principal plane. So this is the answer. If anyone have any doubt, ask me. Otherwise, please write down fast. So we will take next example. If your writing is over, shall I take next problem? Yes. Okay, please write down next problem. Okay, so we will solve next example. A solid shaft. A solid shaft is subjected. Solid shaft is subjected. Solid shaft is subjected to a bending moment of to a bending moment of bending moment of bending moment of 2.3 kilonewton meter. 2.3 kilonewton meter and twisting moment of twisting moment of twisting moment of 3.45 kilonewton meter. Kilonewton meter. Full stop. Find the diameter of shaft. Find the diameter. Find the diameter of shaft. Find the diameter of shaft if the permissible tensile and if the permissible tensile and shear stresses tensile and shear stresses are not to exceed are not to exceed shear stresses are not to exceed 703 Newton per mm square and 421.8 Newton per mm square. Newton per mm square respectively. Okay, so this is the question. So this is the reverse type of question. In this question, permissible tensile and shear stresses, that is sigma 1 and tau shear stresses are given, and from that we have to find out the diameter of circular shaft. So this is the reverse type of problem. Now we will solve. First we will write which parameters are given. So according to this question, following parameters are given. Bending moment, so M, which is equal to 2.3 kilonewton meter. So here again conversion is, so 2.3 into 10 raised to 6 Newton mm. Okay. After that, twisting moment, that is T, which is equal to 3.45 kilonewton meter. So T, which is equal to 3.45 into 10 raised to 6 Newton mm. Okay. Then tensile stresses and shear stresses. Okay. So sigma should be less than sigma should be less than 703 Newton per mm square, and shear stresses, that is tau, should be less than 421.8 Newton per mm square. So that much parameters are given. And here only one parameter we have to find out. Okay, one parameter, and this is the diameter of rod. So D, which is equal to question mark. Now this is the reverse type of problem. So we will solve. Find diameter of shaft by applying permissible tensile stress. Okay, tensile stress. So here two stresses are given. So we will check or find out diameter by using two stresses. So first we will apply permissible tensile stress. That means sigma 1 value is given. Okay. So what is the equation for finding out sigma 1? Sigma 1, which is equal to 16 divided by pi d cube in bracket m plus square root of m square plus t square. Okay, so this is the equation. And here the value of permissible tensile stress is given. So we will put the value of permissible tensile stress. So the value of permissible tensile stress is 703. Okay, so 703, which is equal to 16 divided by pi d cube in bracket. Okay, so the value of moment is 2.3 into 10 raised to 6 plus square root of 2.3 into 10 raised to 6 bracket square plus twisting moment T is 3.45 into 10 raised to 6 bracket square. So you observe here 10 raised to 6 is in all three terms. So we will take common 703, which is equal to 16 divided by pi d cube. Okay, here 10 raised to 6 we will take common. So what is remaining in bracket? 2.3 plus square root of 2.3 square plus 3.45 square. Okay. So you solve this. 703, which is equal to 16 into 10 raised to 6 divided by pi d cube and into. So you solve this and tell me what is the answer. 'Yes, what is the answer? 2.3 plus square root of 2.3 square plus 3.45 square.
6.44.
6.44. Okay. So 703, which is equal to, now you multiply by this 16 into 10 raised to 6 into 6.44.
pi by d square तसंच ठेवायचं ना म्हणा.
Pi by d cube take as it is.
103.14 10 raised 6.
14 into 10 raised to 6. Okay. Then we will apply here. So now we will shift this d cube to left side. So d cube, which is equal to 103.14 into 10 raised to 6 divided by pi into 703. So d cube, which is equal to how much?
4 6 47 46.70 10 raised 3 madam.
4 6
Point
70 into 10 raised
1
to
3.
3 mm. Okay, after that, therefore d which is equal to how much? Take third root of this value. So d which is equal to how much? Yes, d which is equal to how much?
$36.01.
36.01 mm. Okay, so this diameter we got from permissible tensile stress. Okay, now we will check from shear stress. Okay, so next step is find diameter. Next step is find diameter of shaft. Diameter of shaft by apply shear stress equation. Shear stress. So shear stress is tau max which is equal to tau max which is equal to 16 divided by pi d cube in bracket square root of m square plus t square. So the value of tau max is given and this is 421.8 which is equal to 16 divided by pi d cube as it is in bracket square root of m is 2.3 into 10 raised to 6 bracket square plus t is 3.45 into 10 raised to 6 bracket square. Okay. So we will take this 10 raised to 6 common. 421.8 which is equal to 16 into 10 raised to 6 divided by pi d cube. So in bracket 2.3 square plus 3.45 square. Okay. Now we will shift this d cube to left side and this 412.8 to right side. So d cube which is equal to 16 into 10 raised to 6 divided by pi into 421.8 into in bracket 2.3 square plus 3.45 square. So d cube which is equal to how much?
मॅडम ते कॅल्शियम मध्ये काढा ना.
काय झालं? Yes, d cube which is equal to how much?
$50.06 into 10 raised to 3.
50.06 into 10 raised to 3 mm. Okay. And then d which is equal to third root of this answer.
36.85.
Okay, so 36.85 mm. 6.85 mm. So this is the diameter of shaft. Finally, diameter of circular shaft is 36.85 mm. This is our answer. Okay. Anybody having doubt? Ask me. Otherwise, please write down fast.
मॅडम ते मला डी कसा काढायचं ते सांगा म्हणा थोडं.
डी क्यूबचा आन्सर आले का तुमचं?
हाय म्हणा.
हा, काय करायचं? शिफ्ट बटन प्रेस करायचं कॅल्सियरचं
हाय म्हणा.
आणि अंडर रूटचं बटन प्रेस करायचं.
शिफ्ट आणि अंडर रूटचं काय म्हणा. ओके,
हा, आता तिथं थर्ड रूट आलं का ते?
1 मिनिट म्हणा.
मी सांगते ती प्रोसिजर फॉलो करा. पहिले शिफ्ट बटन प्रेस करा, त्यानंतर अंडर रूटचं बटन प्रेस करा. अंडर रूटचं बटन प्रेस केल्यानंतर ब्रॅकेट टाका. ब्रॅकेट मध्ये व्हॅल्यू लिहा 50.06 इंटू 10⁻³ ब्रॅकेट क्लोज करा. मग करेक्ट आन्सर येईल तुमचं.
ओके मॅडम. आले मॅडम, थँक्यू.
Okay, if your writing is over, shall I take next problem? Yes, anyone give me answer?
Yes,
Reply.
ma'am.
Okay, so please write down next problem. A maximum allowable shear stress, maximum allowable shear stress, allowable shear stress in a hollow shaft, in a hollow shaft, in a hollow shaft of external diameter, shaft of external diameter equal to twice of internal diameter, twice of internal diameter, twice of internal diameter is 80 Newton per mm square. 80 Newton per mm square. Full stop. Determine the diameter of determine the diameter of determine the diameter of the shaft determine the diameter of the shaft so the diameter of shaft if it is subjected to it is subjected to it is subjected to torque of subjected to torque of torque of 4 into 10 raised to 6 4 into 10 raised to 6 Newton mm and a bending moment of a bending moment of bending moment of bending moment of 3 into 10 raised to 6 3 into 10 raised to 6 Newton mm. Okay, so this is problem related to hollow shaft. Okay, and here also we have to find out the diameter of shaft. This is also reverse type of problem, so we will solve. First we will write given parameters. So here allowable shear stress is given. Okay, so tau max value is given. Tau max, which is equal to how much given? 80 Newton per mm square is given. Okay, then bending moment, that is m, which is equal to 3 into 10 raised to 6 Newton mm. The next torque is given T, which is equal to 4 into 10 raised to 6 Newton mm. Okay, and here one relation related to diameter is given. So external diameter, that is D naught, which is equal to twice of internal diameter, that is 2 times internal diameter. That means external diameter is the 2 times of internal diameter. This is the relation given, and we have to find out the diameter of shaft. To find, so which parameter we have to find out here? diameter of shaft. Diameter of shaft. Diameter of shaft. This is parameter we have to find out. So we will find here. Now here we have to apply equation for hollow shaft. Okay, equation for hollow shaft. Third one is, okay, find diameter of shaft. Find diameter of shaft. So we have to apply here hollow shaft equation. So here we have to use maximum shear stress equation. So tau max, which is equal to what is our equation for hollow shaft? Tau max, which is equal to 16 d naught divided by pi in bracket d naught raised to 4 minus di raised to 4 into in bracket square root of m square plus t square. Okay, now we will put values here. So tau max, which is equal to 16 into d naught, we will take as it is. Okay, so here we will put the value of d naught. So value of d naught is 2 into di. Okay, so value of d naught is 2 di divided by pi in bracket. The value of d naught is 2 di raised to 4 minus di raised to 4. Okay, into under root of m. M is 4 into 10 raised to 6 bracket square plus t. T is, okay, sorry, I have written wrongly. 3 into 10 raised to 6. Okay, value of m is 3 into 10 raised to 6. So 3 into 10 raised to 6 and the value of t is 4 into 10 raised to 6 bracket square. Okay, so we will take this 10 raised to 6 as a common. So tau max, which is equal to 16 into 2 di into 10 raised to 6 divided by pi into 2 di raised to 4 minus di raised to 4 into square root of 3 square plus 4 square. Okay, now we will put value of tau max. So value of tau max is 80, which is equal to, now you do the calculation of this. 16 into 2 is
32.
32 di into 10 raised to 6 divided by pi. So 2 di raised to 4. So what is the value of 2 raised to 4?
16, madam.
So
30.
16 di minus 1 raised to 4 is 1.
1.
So di, okay, into
5.
5. Okay, so 80, which is equal to 32 into 10 raised to 6 di divided by pi into, now you observe here, 16 di minus 1 di. So how much di is here?
15.
15 di into 5. So here, but here di raised to 4, na? Here di raised to 4. Here also di raised to 4. Because of we have taken 2 raised to 4 and di raised to 4. So 16 di raised to 4 minus di raised to 4, that is 15 di raised to 4. So 1 di and 1 di gets cancelled here. Okay, 1 di and 1 di gets cancelled. Now we will rewrite once again. So 80, which is equal to 32 into 10 raised to 6 into 5 divided by pi into 15 d cube. 15 di cube. Okay, now we will shift this di cube to left side. So di cube, which is equal to 32 into 10 raised to 6 into 5 divided by pi into 15 into 80. So you calculate the value of di and tell me di cube, which is equal to how much? di cube, which is equal to how much?
$33 ಅಲ್ಲ ಮೇಡಮ್ 34.88 ಮೇಡಮ್ ಡಿ
I am asking di cube.
మీ డాడ్ ఆన్సర్
Okay, so di which is equal to 34.88
88 మేడం
mm, but give me answer di cube which is equal to how much? Because of I have to write here. No?
బాగా
42.44 into 10 raised to 3 di cube
42.44
4
into,
point into 10 raised to 3.
into 10 raised to 3 mm, and then di which is equal to 34. So this is the internal diameter, and we have to external diameter. So d naught which is equal to 2 times of internal diameter. Therefore d naught which is equal to 2 into internal diameter is 34.88. So therefore external diameter which is equal to
69.76
69.76 mm. So this is the answer. So if hollow circular shaft is given, then you have to use the equation of hollow circular shaft. So this is the answer. So please write down fast. Okay, so today we will stop here. In next lecture, we will start equivalent movement and equivalent torque. Okay, thank you for attending lecture. We will stop here.